Do you want to be paid to learn blockchain? If you complete the Nervos Hackathon training, you can earn $340. You just have to follow the steps of the tutorial and it only takes a couple of hours. And in this video, we are going to follow the first few steps of the hackathon training. If you don't know me, I'm Julian and on Eat the Blocks, I teach blockchain development. Nervos is a next-generation blockchain that aims to be flexible, scalable, and interoperable. The goal of Nervos is to create an intermediary layer between existing blockchains by allowing assets and liquidity to move easily across different blockchains. This means developers can build a dApp one time and make it available to users on multiple blockchain ecosystems without having to make any modification for different blockchains. There are already some other projects which tackle this issue, but most of them are focused on crossing the bridge between blockchains that use the same technology. Nervos is working on a harder problem, which is to bridge the gap between blockchains that have a different technology in a way that is transparent to the user. Nervos believes that the blockchain experience for a user should be as easy as opening a website in a web browser. And for developers, just like with web development, you should be able to build your dApp once and have it available to everyone. Nervos uses a multi-layer architecture where the main blockchain is used for security and decentralization. That's what we call layer 1. Secondary blockchains are used for scalability. That's what we call layer 2. The native coin is called CK Byte or CKB for short and is what is used to pay for transaction fees. One of the L2 blockchains of Nervos is compatible with the EVM, short for the Ethereum Virtual Machine. This means as a blockchain developer, you can reuse a lot of your Solidity skills to create smart contracts or Nervos with very little modification. Okay, that's it for the high-level overview of Nervos. Next, we are going to start the hackathon training. So I'm here with Jordan of the Nervos network. So Jordan is a senior developer at Nervos and is going to help me to complete part of the hackathon. Hi, Jordan.
Hey, Julian, how are you doing?
Hey, I'm good, thanks. So here, this is the description of the hackathon on Gitcoin. And so we are going to go through tasks from 0 to 4. Let's get started. So we're going to start with the first task, Gitcoin 0 here. So I understand that I have to set up a local node. Is that correct?
Yeah, that's correct. We actually have two pieces of software we're going to be setting up here. This is a CKB node, which is it's a full node that we're going to be setting up on the testnet, and then a secondary piece, which is called the CKB indexer. And this is split off for a reason, which I'll describe later. But basically, this is the same software that you'd be running for any other blockchain, except in Nervos, we've split it into two pieces.
Okay, I understand. And so these nodes, they are running on Nervos L1 or L2?
These are layer 1 here. These are the main nodes that are required for consensus and building dApp applications.
So let's go through the instruction. So if you have not completed the instruction, go in the task setup. Okay, so here we have the instruction on GitHub. So supported environment. So me, I'm on macOS, but if you are on Windows or on Ubuntu, it still works. So let's go on macOS. Okay, let's scroll down. Okay, so Xcode, command line tools. So I already have them. Curl already have it. Version of 7-zip. Okay, so let's download this. Okay, so now we have 7-zip. So Node.js, we do have it. Python. So I think I have Python 2 and 3. Yarn, I think I do have it. Yarn version. Let me see. Okay, I have it. Docker, I do have it. Okay.
Okay, and then what version of Node.js do you have running?
Yeah, 12.
12.13. We can give that a try. I'm not 100% sure if that's going to work. We generally recommend version 14, which is the LTS version, but I'd say we just go ahead with this and give it a try, and we can upgrade it if we need to.
All right, so now back to our main page. We are going to set up the local node. Okay, so we're going to make a project folder. Then set up a CKB node.
Back up a second. The first step there says that you actually have to follow a separate guide. So there's a second guide in there that you need to go into.
All right. So run system requirement to run a CKB node and download the following. Okay, so let's go there. And then we're going to download. So this is the zip file with the binary, I guess. And so here
you gotta keep scrolling. In the instructions specifically stated to use version 0.43.1, I believe. So scroll down, keep going a little bit further there. There we go. 0.43.1. This is the one we want here.
Yeah. Okay. So very important detail. You have to pay attention to the version. Okay. So let's click on the zip file here. Okay. Yeah. Keep. All right. So then I guess I have to unzip it. Okay. So now we have it. So 7ZZ and then CKB. Okay. Let's unzip this. Because I forgot the point and forward slash.
What about the unzip command? Does Mac have just that one? Unzip?
Yeah. Okay. So now to verify that it works, I need to do CKB version. So let's try this.
Okay, we probably need to indicate do a dot and forward slash before CKB to indicate it's the current path to execute. Yeah, take out that space though. There we go.
All right.
Okay.
So now we need to verify that the CLI executable is working too. Okay, great. We made it. Then what's the next part of the instruction? So connect to the Agron testnet. So Agron, is it a L1 testnet?
That's right. This is the layer 1 main testnet. It's a shared testnet that everybody's going to be using.
Okay, so I guess it's like the testnet on Ethereum. We can get some free crypto to pay for our transactions.
Exactly. Nothing has any value on the testnet, so we'll be able to use the faucet to get some free CK bytes.
Okay, so now we are going to start a node. Is it going to download the whole data of a testnet?
It is, but first we need to configure it, and that's what this command is doing. It's telling it to use the testnet. You can also specify a devnet or the mainnet at this step, but we're going to configure it at the testnet. And then after that, right after that, I'm going to take you through the process to download a snapshot to bootstrap it so we don't have to wait 5 hours for the thing to sync.
So here, let's copy paste the instruction. So I'm going to add a point and forward slash here. All right. Oh, so this is written in Java, I guess.
And no, actually, this one is written in Rust.
Okay. Oh, yeah. Toml. Oh, yeah. That's true. Okay. So it has created the Genesis hash, which is the same as for on the other nodes of the network, I guess.
Yeah, that's correct. That matches up with the rest of the testnet nodes, and that indicates that it's a very specific instance. So the next step here would be to run CKB space run. We're going to skip that at this stage, though, but that's what you would do to start the node and do the normal syncing process, which would take 5 to 6 hours usually to fully sync. But at this stage, we can actually stop right here and go back to the Gitcoin instructions, and there's a bootstrap that we can use.
So to set up a testnet CKB node, but you can speed up the process by using a bootstrap. Okay, so basic instructions for the bootstrap are available on CKB tool, but you can use this script below to automate the process. Okay, so basically I just copy paste this and it will magically work.
It might. That's actually designed for Linux, but we can go ahead and give it a try here. I suspect it won't work because the 7-zip command is a little bit different, but hey, I say let's just go ahead and give it a try. All
right, so let's try this.
Okay, so it's at least doing the first part of the process here, which is good. What it's doing right now is it's downloading a snapshot of the testnet blockchain. Now, normally, if you were doing mainnet, the real network with real assets that have value, you wouldn't ever want to do this. The reason for that is that a malicious entity could feed you a fake blockchain, and then it would be insecure. But since we're just doing the test net here, it really doesn't matter. So that's why we provide a free bootstrap that you can use to make this process much faster here. So this is going to take a little while here, it looks like. It's a little 6.8 gigabytes to download. But if you have a fast connection, it takes me about 10 minutes to do. May take a little longer here.
Okay, so it seems like we are done for the snapshot of the node. Okay, so now we can run our node, right?
Yeah, so that's going to be /CKB. That's the main executable. And then just the command, it's space run.
I love it. You know, when I say this, I feel very smart. I feel like a hacker.
I believe the correct term now is shadowy supercoders. That's what we are, according to
oh yeah,
Elizabeth Warren, that's her name. Yeah. Okay, so I can also see on your screen here the block it's on it's a very high block number, so that means that it didn't start at 0. So yeah, it's just catching up the last bit here, but it's got most of the information it's going to need.
We're going to continue with the other steps. So then set up a CKB indexer. So there is a bootstrap also, apparently.
Yeah, this is another bootstrap. It's the same basic process that happened in the other one, and it has the convenience script as well. But the indexer one, the bootstrap is much smaller. It's about 1 gigabyte as opposed to 6.8, which I think the other one was.
Okay, so we are going to download the binary of the indexer, but here we need to be careful because on the instruction here, this is for Linux, but if you have a Mac, you need to go to this page, the release page on GitHub. All right, so let's see this. And do we know which version we need? 0.2.1. Okay, so 0.2.1 here. Let's select this one. Okay, and here we want the macOS version. Okay, so it's downloading. Okay, so CKB indexer. All right, so I'm going to move this to my current directory. CKB indexer. Here. All right, so now I have it. After we are going to unzip it. All right. Now we have another
zip file. I'm going to have a talk with them. I don't know why they're doing that.
All right. So
probably a broken build script, I suspect, that's double zipping everything. But yeah, we'll get that.
All right, let's unzip again. So CKB indexer Mac. All right.
It looks like it dropped them into the current directory. So we'll probably just need to move that stuff into its own folder. Yeah, we need to make the folder and put those in there.
mkdir CK. Then let's move CKB indexer there. CKB indexer. All right, so now let's go in CKB indexer. All right, let's go back to the instruction. It tells us to change the permission of the executable, but we might not have to do this because maybe we already have the correct permission here, executable -x, so it should be fine. But on Linux, we might need to do this. Then we need to download a bootstrap.
Yeah, again, this is an optional step. It will speed things up if you have a fast computer and a high bandwidth connection. It's downloading approximately in the bootstrap is a gigabyte of data. If you're doing the main synchronization without bootstraps, though, then all you have to do is set them up and let them go. But again, that's probably going to take 5 or 6 hours. So it's up to you if you want to save time or not.
Basic instruction for the bootstrap are available, but we can download this. We can use this script. But again, that was a script for Linux, so it might not work.
Probably not going to work right for Mac. No.
Okay, so let's try this. At least it will download the file okay, I guess.
Yeah, I think so. Yeah, it's going to have trouble with the decompression because there's several available clients for Macintosh, and they're a little different each one.
All right. Is there anything else we can do in the meantime, or we are stuck now?
Well, in general, for most of the people doing this, we recommend that you go ahead and finish one at a time so you don't get mixed up. But we can probably go ahead and start with the other ones. But like this one here, this challenge here, task 0, is a pretty easy one. It's just to set up the nodes here. And I mean, we basically almost have it done, except for, of course, synchronizing the data and actually launching the command to get it started.
Once everything will be ready, so we'll have 2 URL here for our node and for our indexer. But as a developer, do you ever interact with the indexer, or is just with the node?
You're going to interact with both of them, actually. The CKB node, this is the main node that's used for consensus. It's used for sending transactions. The CKB indexer is a specific type of node that gives a different kind of information. It has a lot more overhead to it. It's indexing a lot of the actions that are going on with the blockchain. And so as a developer, you specifically would be using the indexer for a lot of different things, which we'll start to go into it in probably a different tutorial series. But for now, what's important here is that you need to know that both of these nodes are required for a developer. Now, the case when you wouldn't need both nodes is if you were just running a node to benefit the network, then all you have to do is run the normal CKB node, not the indexer, because the indexer is specifically for developers. And that's, you know, just like a lot of people like to run their nodes on Raspberry Pis and stuff for Bitcoin or something like that. We have the same ability to do that, even though we have much more complicated software that executes smart contracts. And this is part of the reason we split it apart. It's to make the regular node, the CKB node, have much lower requirements for users that want to run it on a low-end computer to benefit the network, but they're not necessarily developers. They don't need the full capability.
And next, we need to run the indexer. So, oh yeah, this one.
Yes, there it is. Yes.
All right. So, okay, our indexer is running too. So I think we're good to go. So when you're a developer and you want to interact with the network, I guess maybe you don't have to specify if you want to interact with the node or the indexer. Maybe you use some tool that automatically writes the request.
Yeah, usually the frameworks involved, well, they'll probably ask you for the URLs to both, and then they'll handle the details and pulling the information that they need. And you just need to worry about the framework. Yeah.
Oh, okay, so that's the important part to know. Okay, so I can see here we also have some URL for the public testnet. So this is useful in case we don't want to run our node. So I guess here the big drawback is that every time you do a request, the latency is maybe a couple of 100 milliseconds or a couple of seconds. So the developer experience is a little bit worse.
Yeah, it's going to be slower. Also, synchronization, like we said earlier, that the CKB indexer, it pulls its data from the CKB node. And so for it to do its own synchronization process, if you're doing that over the internet, it's very slow compared to if you were just doing it locally. So generally, if at all possible, we always suggest to developers that you set up both of these nodes locally.
Then the next step is the task submission. So I guess we're not going to do it, but actually with Gitcoin, there is this system where there will be judges that check out your screenshot and then they mark your task as done. Does it work like this?
Exactly. Yeah, exactly. Yeah. At the bottom of every task, there's some instructions on what you need. Usually it's a screenshot or it's a URL or a piece of information that we request you just copy and paste. It's pretty simple stuff. And our judges will take a look at that to verify that you actually did the challenge. And then you get paid for it. I mean, this is really a pretty easy thing to do for most people here, just to set up a node.
We can start to check out the next task. So next step, this one. So in this task, we're going to create a God-woken account on the EVM layer 2 testnet. Okay, so several interesting things here. So EVM testnet. So that means we'll be able to deploy Solidity's smart contract because the EVM is the Ethereum virtual machine, but that has been adapted for Nervos. Is that correct?
Yes, that's correct. You're able to use Solidity smart contracts on Nervos, and it runs very similarly to the way it would on native Ethereum, except it's running on a layer 2 optimistic rollup engine, which actually has significantly higher throughput than Ethereum. So it's going to run faster with much lower fees for all users.
And another thing that I find interesting is this word here, like God-woken account. I love it. What is this?
Yeah, so God-woken is the framework. It's one of the frameworks that we use, and this one is specifically for optimistic rollups. And so when you're creating a God-woken account, basically what this is saying here is that you have to kind of initialize the system for a user when they're going to use layer 2. This is part of it's kind of the reason we have to do this is kind of buried in technical details, which I won't really go into. But what's important to know now is that your users, each one of them is going to have to initialize the system before they start working with it. And we do this just by making a deposit. It's really a simple way to do, and that's what the challenge is here.
So the God-woken is like a framework for developer, or it's part of the layer 2?
It's actually both. It's available, it's open source, so anybody could set up their own layer 2. But to keep things easy, the Nervos Foundation is using God-woken to make a specific layer 2 instance, which everybody can use for EVM, and they don't have to worry about setting up God-woken.
Okay, so it's a tool to easily work with layer 2 on Nervos.
More or less, yeah. I mean, it's actually tools, plural, tools and a framework. It powers the layer 2, and it's also a set of tools to work with it. So yeah, it's a whole bunch of things.
Interesting. It seems to me a little bit lower level compared to Truffle, because it seems it's also used by the core developer of Nervos themselves.
Yeah, and actually the Truffle is a very common tool set within the Ethereum ecosystem, and we're actually going to support that as well. We use that in some of the later steps, so that Ethereum developers will be able to use many of the same tools with just minor adaptations to be able to use it with our layer 2.
Let's scroll down and see what we can do. So Nervos support the use of Ethereum compatible smart contract in a layer 2 based execution using the God-woken and Polyjuice framework. Okay, so Polyjuice, another interesting words.
Yeah. These again they're kind of like two halves here. So God-woken is specifically for optimistic rollups, and Polyjuice is specifically for EVM. And the two work together to create this layer 2 system. And the reason that they're separate is because God-woken is not specifically limited to EVM. That's just that's our first phase here. That's to bridge compatibly with Ethereum. But later on down the line, it's also going to support smart contracts from other systems as well, possibly like Cardano, Tron, EOS, like any of these. All of these have the capability of actually running on top of Nervos.
Okay, so I guess something comparable in the blockchain ecosystem would be the parachain of Polkadot, where you can create other chain, but with different consensus layer. You currently support EVM, but in the future there'll be others. Yeah, so it's very modular.
Yeah, I'd say it's actually very similar. A lot of if you get into the details about the design of all these next generation systems, Nervos, Cardano, Ethereum 2.0, and of course Polkadot, there's actually a lot of similarity to the way that they're operating. However, they all use completely different naming, so you probably wouldn't be able to tell. You'd have to really get into the details.
I have to say, for the choice of name, like, you guys win hand down. Yeah. All right, so EVM DApp, using the popular MetaMask wallet. So okay, I already have it. So I need to install this. Okay, so in the first task, you'll create a God-woken account on Nervos EVM layer 2. Okay, so the basic process for creating a God-woken account is create and fund an account with CK byte on layer 1, deposit some CK byte on layer 2. Okay, so because we're going to use layer 2, there are 2 steps. So first, I'm guessing there is probably a faucet somewhere to get this CK byte.
Yeah, that's right. Yeah, right here we're going to be using the tutorial there in the link there. It's going to take you through the process of creating an account using CKB CLI, and then we're going to fund it using the faucet.
This can be accomplished easily using the CKB CLI that is included with the CKB node software. Free testnet CK byte can be obtained using the Nervos software. So for instruction on completing this step, please follow this tutorial. All right, so let's check this out. Okay, so let's scroll down here. Install the CKB command line tool. So don't we already have it because we already installed the node before?
Yes, and actually right there on the first line, the note says that it comes with the software. So if you're running your own local node, like we were trying to do, you already have CKB CLI. This instructions is more included for people who are using public nodes, in which case they're going to need to still get this software.
Okay, got it. Then.
Right. So since we're not setting CKB CLI up, we can skip through most of this here and keep going. And here we are. Now, there, CKB CLI, we're creating a layer 1 account.
Okay, so I guess we're still not done with downloading the Bootstrap, but I guess this is independent.
It is dependent on a node, but we can use a public node for now. We're just going to need to, let's see, I can't remember exactly how to do that. We're going to have to look into help options about how to use that with a public node.
We're going to create our account now. And so for this, we're going to use the CKB CLI utility. And I think the full command is account new. Is that correct?
Yeah, that's right.
And so this is an operation that is done client side. So there is no interaction with the blockchain there.
Yes, that's right. This is just generating new private keys and public keys and addresses. Yes.
Yes, it's just like any other blockchain where basically the probabilities are extremely low that there ever be a collision with the two addresses. Okay, so let's do this. Your new account is locked. Please give, okay, so let's give a password to this.
Yeah, since this is just a test net, I'd probably recommend something really simple just because it doesn't really matter. It'll help you to go faster. But if this was the main net, of course, give it a very strong password.
Right. Okay, it seems like the script hang there. Okay.
Yeah, it was probably, yeah, I was trying to do its synchronization is what it was going on. That's probably why I was hanging. But yeah, that's the end of it right there. That's created the account. So you probably want to copy this information just so we have it for later and just put it in a text file or something. And then the next step is we'll extract that private key.
All right, so these are my notes. Okay, so let's put this. One thing interesting here is that the address is not the same thing on mainnet and testnet.
Yeah, that's right. We put a checksum in there to specifically make sure that these are different. And the reason for that is we didn't want people to ever have to worry about making the mistake of sending testnet funds or mainnet funds to the wrong place. So there's two separate addresses for each network. The lock argument is kind of like it's on Nervos the equivalent of a public key. It's actually a hashed and truncated public key. It's used for some applications are going to require it. And a lock hash here is kind of like an alternate form of the address. Again, it's just kind of like whatever application you're dealing with, it might ask you for something slightly different, a different form. And so all that's important is that these pieces of information you see on the screen now, they kind of go together. But most of the time, especially with the instructions we're just going to be working with the testnet address.
Okay, got it. Now let's go back to the instructions. So we have created an account. Then what's the next step? So we can get some testnet CK bytes. So for that, we're going to need to go to the faucet and we're going to enter our wallet address. Let's check out here our notes and we copy paste the address for testnet. All right, so claim.
Okay, and as soon as you click it, it should put you, if you scroll down a little bit here, it should put you into a pending state. That's probably you at the front of the line here. If there's a lot of people in line, sometimes it can take a little while, but usually you'll get it within a minute or two, and it'll give you a good amount of, it looks like it's currently distributing 10,000 CK bytes per request. And you can get that once every 24 hours. But that's on Nervos, that's a lot of CK bytes. That's enough to do a lot of stuff.
Okay, actually we can verify this on your blockchain explorer here. Live sale So we don't see the deposit yet. So I guess because we have to wait before we have more confirmation.
Yeah, it needs to process. And also, I don't know if it's actually been sent yet. Like I said, there's sometimes a bit of a line. Oh, there it goes. It says it's been processed now. So
okay, so if we
refresh this.
10,000 CKB. Okay, so I guess we're good.
Yep, we're good.
Yeah, all right, awesome. So let's see here. Do we still have something else to do? Yeah, check your account balance. Yeah, CKB Explorer, yeah, so we were already there, but you can also search for addresses here. Yeah, it's like a ether scan basically for Nervos, and I guess you can put address of a transaction hash also, and it will give you some info. And so here we can see one transaction. So this is probably the address of the faucet that sent us 10,000 CKB. Yeah, and in the same transaction, it also sent some CKB to another address. But yeah, this is someone else.
Well, yeah, that's the change address there. That's how the Nervos uses something called the cell model, which is, it's kind of like a descendant of the UTXO model used in Bitcoin. So this is the equivalent. What you're seeing here is like somebody hands you a $20 bill to buy something, but it only costs $5. Well, you have to hand them back the change, which would be $15, right? So that's, if you add up those numbers there, they add up exactly to the input amount, which is on the left side. On the right side, you see how it was broken down. 10,000 went to you, and the remaining 6.5 billion or whatever that went back to the same address where it came from.
Okay, so let's go back to the instruction. So I guess we almost done. Okay, export your private key. So here we have a command. Okay, let's copy this. So replace your log arg. Okay, so that was part of what we copied. Yeah, your username. So username you use on your laptop. So let's go back to the terminal, paste the command. Okay, first we're going to replace log arg. Okay, log arg here. Okay, was it a 0x? Yeah, there was a 0x, and extended private key. I'm going to put my username here on my laptop.
Right, and actually on a Macintosh, it's going to be a little bit different. I forget exactly what the folder, but I think it's users is the folder instead of home.
Oh, yeah, so on Mac here, it's not home, but it's users. Okay, so let's do, oh, and we are missing one letter here, so CKB. Okay, enter.
And need the / too, just to specify that it's in the current directory. There we go.
Okay, so success exported account. Please use this file carefully. So is there any reason why the account creation is not done in one step? Like you just launch account new and you just create everything?
Well, what we're doing here is this process here, we're exporting the private key so that it can be used with applications. When we created the account before with account new, that was just a one-step process. It was already done at that point. And that's why we were able to go to the faucet, right? And we were able to get funds. What we're doing here is we're exporting the private key so that we can give that to applications which are going to manage your account for you.
Oh, okay. Next, I guess we view your private key. Okay, so here let's check that everything worked fine. So
right, so the cat command is just to view it, yeah.
Okay, got it. We have our private key. So I guess we can.
Right, so let's grab that top line though. What it's saying is here is that you need that top line. That's your actual private key. And you probably want to put that into the same folder with your other information because we're going to need that again later.
All right, so let's do this. And do we have to prefix it with a 0x?
We do need to prefix it with a 0x, and we only need that first line. We actually don't need the second line at all. That's some other data used by the wallet that's not important.
All right, let's copy this and 0x. All right.
Now we still have to complete the second step here, which is to actually execute the command with that private key, which is going to create the account. So there's a separate tutorial for that down at the bottom there.
Okay. Here, I deposit some CK bit on layer 2, this one.
Yes, that's right.
So for this, this tutorial, right? So
right.
Create a Godwoken account by making a layer 2 deposit. So to set up the Godwoken example tool package, follow this tutorial. Here we're going to install some development tool to interact with your L2.
Yes, that's right. Yeah, it's the Godwoken examples tool package. This is just a bunch of tools that were put together to interact with the layer 2. This is not the final tools that developers would be using in say 6 months from now. But at this point, this is what we're going to be using for the Gitcoin challenges here.
We need to install the account CLI tool. We are going to git clone this thing. All right, so let's go back here. So I guess we're going to go to the root of our project. We're going to git clone this. All right. Next, we're going to the Godwoken example. We're going to run this command. Okay, so we have run this command. So next, there is another command. Let's run this. Okay, that was fast. Your tool should now be ready to start interacting with Nervos Layer 2. The account CLI tool, we need to sync with testnet on first usage. At this stage, if we are running our local node, we need our local node to be sync up, right?
Yeah, that would be highly beneficial. If you're running remote nodes, you can still use this, but it's going to go through another one of these synchronization processes. This is unfortunately one of the things that happens when you are dealing with these decentralized software, is there's going to be a lot of synchronization involved. Fortunately, once you get these nodes up and running, you don't have to do it again. They just kind of keep running in the background and you do their thing without any intervention.
Speeding up account CLI synchronization by using snapshot data. Okay, so there is another snapshot to import. So this snapshot we're going to import, is it for L2?
This one, let's see, account CLI. It is pretty much, it's L1 data, but it's actually being used with an L2 tool, and it has a different format. So yeah, it's the same basic process as the ones before. This is going to be similar amount of data as the existing indexer. So it's about a gigabyte of data that's needed.
So here we are in a Godwoken example. We're going to need to make a script executable. Let's make this script executable. All right. And after, we just need to run it. All right. Okay, so it's going to take some time to download it, but it's going to be slightly faster this time.
So here, look, I'm seeing it looks like it got, if it finished up here.
Yeah, okay, great. Do we have any other instructions? After this process, start the account CLI tool again. What was the command? It's just account CLI?
Okay, so account CLI, yeah. So the full command is, this was actually, this tutorial here was just to set it up, which we've done now. If you scroll down a little bit more, it actually says that you can just test it using these commands here. So
yeah, okay.
Just scroll down a little more. So that's how it's executed there. There's a command.
Okay. So replace your Ethereum address with Ethereum address to convert. So is it the address we created before?
No, the address you created before was a CKB address. So this would actually come from MetaMask. You just want to pull in an address.
Okay, here I copy paste this, and then I'm just going to generate a new account for testing. So here, let's create a new account. So we're gonna call this Nervos. All right. Okay, so here I copy this, and then I replace with an address. Okay, so what was the point of running this command?
Okay, so right now, all we were really doing is we were just testing to make sure that account CLI works. But at the same time, we figured we might as well just show you one of the commands that it does. And this is conversion of an Ethereum address to a Godwoken short address, which is also sometimes known as a Polyjuice address. And the reason for this is that our layer 2 system needs an address that is common for whatever blockchain you're using. And that's the Polyjuice address that we're seeing here that was converted to. Because like with Nervos, we're not specifically dealing with just Ethereum. We're also talking about potentially in the future other blockchains, EOS, Tron, Cardano, whatever we're interfacing with. And all of these need to have some way to kind of link them together. And that's the address you're looking at here, the Polyjuice short address, or I guess it's calling it a Godworken short address. So again, this is all we want to do is we probably want to copy this information into the same text file we had before, because we may need it later for some commands here and there.
So for example, you could use this command to transform a Bitcoin address to Nervos.
Right, exactly.
All right, so here, let's copy paste this. All right. So next, what do we need to do? Let's scroll down, Polyjuice account conversion. So yeah, we've done it. And now convert a Polyjuice address to an Ethereum address so we can do it the other way around.
Yeah, we could do this the other way around, but there's actually a note here that this is not going to actually work until after we've created the account. And so since we haven't done that, we can just skip over this one. That's okay. Like this is just, it's the opposite one. It's mostly included here just for completeness.
Okay. I guess now are we done with that was test one?
Well, we have installed the tool, like on your tabs there, you go forward one. We've installed the tools package here. So now we need to scroll down a little bit more. Okay, so scroll down here. We need to use the command to execute the layer 2 now, or to make the deposit to layer 2. It's saying get your private one, or your layer 1 account private key, which we should have stored in the text file.
Okay, so we do have the private key. Okay, so we copy this thing here, and we're going to import it in MetaMask, right?
No, actually, if we go through the instructions, go back to the instructions. It's telling you the data you're going to need right now. So we have this first part here, the private key. We already have that in the text file. The second part it's asking you for is the Ethereum address, and we should have that too. So just keep scrolling down. Eventually, we'll get to the command portion, which is going to tell us here's the command, and then this is where you're going to insert the pieces of data that we need, right?
Yeah, so we need to use the account CLI to make a deposit by providing your private key. So here we're going to send some CKB token from our initial address to this Ethereum address.
Yeah, that's right. And what's going on here is we're taking CK bytes on layer 1 of Nervos, and the CK byte is the native token there, and we're going to deposit them into layer 2. And so once they go from layer 1 to layer 2, they have to be associated with an address. And since this layer 2 in particular is Ethereum based, it uses an Ethereum address. So we're sending from our layer 1 address to our layer 2 address using this command here.
Okay, so let's copy this. Okay, so let's do this in text file. So insert testnet RPC URL.
Right, so that's the URL that we had set up for the Gitcoin, or excuse me, the CKB node, and that should be in one of the documents here, one of the first tutorials.
Oh yeah, here
we are. Yeah, so it's that first URL there. It's the CKB node RPC URL.
Then for the private key, this is our private key above, right?
That's right. It's going to be the layer 1 private key from our account.
Then your ETH address, so it's that one.
Yes, that's right.
It's not the Godworken short address.
Not in this one. Certain different commands are going to ask for different address types. This one wants the Ethereum address.
Okay, and Shannon. Okay, so I don't remember the unit. Is Shannon is not like Way, right? It's above Way.
It's similar to a Satoshi in Bitcoin. There's 100 million per single. So if you go back to the example, you could actually just copy and paste that amount. I believe there's a minimum of 400 CK bytes, which is a big number. And it's, let's see, if you scroll to the end of that command right there, you should be able to see it. Just scroll to the end of it.
All right, so let's take this. Okay, so that's the elementary unit for CKB. All right, so let's verify if it looks right. So deposit, we have our URL, we have our Ethereum, we have our private key, Ethereum address, and the amount. So now we copy, paste this.
Okay, and since it still needs to catch up with the indexer, this is every time that it runs, the indexer does have to be in synchronization with the network. And so it's starting at 98% because we already used the snapshot to catch it up. So it's just still got a little bit to go here.
So it's really the main focus of Nervos is to be an inter-blockchain solution.
That is the solution that makes a lot of sense. It's more or less like an inherent one. Nervos is actually geared towards flexibility, and that's one of the possible use cases. It's the obvious one. Because it's so flexible, it can adapt to any of these blockchains that are out there, regardless of what kind of shape or size they have, and adapt to whatever they need. And so it's a different approach to interoperability than some of the other blockchains out there, whereas we're actually trying to natively interface with them rather than take these approaches of trying to meet halfway. We just kind of go all the way. And so that's why in some of the materials that we put together, we actually state openly that MetaMask, even though it was designed for Ethereum, is the primary wallet we recommend you use with Nervos as well.
Yeah, I think it's a very good idea to try to reuse Ethereum tools as much as possible because you already have a lot of installation. So for people, it's they're already set up.
Yeah, exactly. I mean, and with some of the application demos that we have, you can actually have users go out from Ethereum with MetaMask. They don't even have to update their settings at all. There's zero setting changes. They just go to the website, start interacting with the dApp directly, and they won't even know they're on Nervos. It's very simple.
All right, so we almost sync up.
Okay, it looks like it's running. It made the deposit transaction, and now the script is waiting for it to confirm.
Okay, let me scroll up to see the output. So do we have a transaction hash already?
Yes, I see it at the bottom of the screen there, just scrolled off. There was actually a transaction hash. And yeah, that's the layer 1 hash, I believe. It's been submitted, and then it has to go through the process of being committed. And there, it looks like it was committed now. And now it is now on layer 2 effectively, but the layer 2 validator nodes, block producers, they still have to pick it up. They have to detect it and basically do the second part to actually activate it and make it part of layer 2, right? They produce the blocks there. So the first step is it basically the deposit locked up your funds on layer 1. And now on layer 2 here, once the block is produced, it releases the funds on layer 2.
And this process of locking the fund on layer 1, so does it go in a dedicated smart contract, or is it a native feature of the blockchain?
I think it's actually it's a combination of a couple different things, but ultimately it is smart contracts because there's one of the goals with Nervos is to be extremely flexible. So pretty much nothing is hard coded here. Everything that is being done, the entire development of the layer 2 required no special provisions. A very knowledgeable developer could come into the ecosystem and rebuild all of this without having to do any hard forks or anything. It'd be a lot of work, a heck of a lot of work, but it can be done. Whereas on other blockchains, like if you wanted to do such a thing on Ethereum, there'd probably be a hard fork you'd have to wait for. You'd have to, campaign for certain features to make things happen. But on Nervos, that doesn't actually exist. It's very, very low level in the sense you can just build whatever you need, insert any kind of cryptography, any new facilities. It's a blank canvas pretty much.
Okay, so very interesting. So now it seems like the whole process has completed. So I guess we can go to the blockchain explorer and see for ourselves
let me see, where is the CKB Explorer? So here, if I search for my transaction, I can see something. So here,
yeah, we can see actually there's the deposit that you made. It's the output is number 0 there. That's the deposit. We gave our value in Shannon's, of course, but it amounted to 1,000 CK bytes there. And so that's the actual deposit that went through.
when it comes to the transaction on layer 2, is there also a blockchain explorer for that?
There is a blockchain explorer. I don't think it's been released today. That one's due in about a week or 2. So it didn't quite make it for the beginning of this the Gitcoin challenges here.
Okay, so let me see. Let's go back to the tutorial. So we have made the deposit, and I think we are done for this step, right?
Yeah, we're done for this step.
The next step is to deploy a simple Ethereum smart contract on Polyjuice. Compiling and deploying a smart contract on Nervos EVM is a process that is very similar to Ethereum. Okay, so that's very good. The end goal of Polyjuice is to provide 100% compatibility with all EVM-based stuff. All right. So prerequisite: prepare your Ethereum private key. So in the previous class, you extracted the private key of your Nervos layer 1 account. So that's what we have in our notes. This private key will be used to deploy your smart contract on layer 2.
So this comes out of MetaMask. We need the private key for the account that we just funded. We made a deposit to an Ethereum account on layer 2. And so we need that private key now. So this is that's what this step is.
All right. So for that, yeah, this is Nervos. So let me see, to get the private key of this, I think this is account detail. Export private key. Right. So private key here. Okay, so that's fine. So then we have the private key.
Okay, so now, yeah, we're just getting we need to pull down one more repository here. I believe this is the last one we'll need. This is just it's actually the same repository with all the instructions. It has a couple more pieces of example code that we put together to make things easy.
Okay, got it. So you know what, let's create another tab. Okay, I need to git clone this. Okay, what is the instruction after? Yarn install all. Okay, so Gitcoin instruction, yarn install all. And after, what do we need to do? So we need to compile the smart contract and copy the artifact. And for that, we are going to use Truffle. So if you're a blockchain developer, you're going to feel very comfortable here. Using the Truffle compiler. Okay, so provided below is a simple smart contract example you can use.
Right. So here, let me explain a little bit of what's going on here. So we're going to be using, in the example here, we have a script that's already, a Solidity program that's already out there, Solidity smart contract that has been set up. And by using the commands here, yarn compile, which is on your screen, it's going to compile that using Truffle. So what we've been downloading and what we're putting together is basically just a couple scripts that have helped to automate this process. Now, also in this instructions here, it also says that if you prefer a different compiler, like if you're already a Solidity developer, you don't have to use our tools. You don't have to use Truffle. You could use Remix if you want to, or something else. You can use whatever you're comfortable with. All these steps here is just to basically compile an existing smart contract. And we provide in here one specific one. It's called simplestorage.json or simplestorage.solidity. And that's pretty much the easiest one we could come up with. I believe the instructions say you can use this one, but we do encourage people to use a different Solidity smart contract if you have one in mind that you can use.
So next, we are going to compile our smart contract. Yeah, compile. So I guess this is a Truffle project here.
Yeah, so the example code here is using Truffle and Docker to compile the smart contract that actually pre-exists in this directory. But again, like they always encourage that you use whatever Solidity code that you're familiar with. If you have something different, please use that. But it does include a very simple smart contract called simplestorage.sol. And let's see, it looks like it encountered a warning, but it was still successful. So yes, this has been done now.
Awesome. So now we have our contract compiled, and after we are going to deploy the smart contract by using Web3. For that, we can use the script index.js, where you have the deployment script. So here, Web3 is already used for Ethereum. We can use it as well for Nervos.
Right. But before you do that, you actually have to modify index.js. In the second paragraph there of this step, it tells you have to insert your Ethereum private key.
So let's do this. Here, let's find the Ethereum private key. Where's this? Oh, Ethereum private key. All right, so here, this is it, Ethereum private key. We copy, paste this from our notes, paste this here. Okay, I think this is the only time we have to change it. Yeah, I think we just have to change it once. Okay, so let's save this and quit. And after that, we're going to run this script node index.js simple storage.json. So this JSON file, this is the contract artifact that was created after we compile our smart contract. And so we run this, it's going to deploy our smart contract. And it's able to do the deployment because now we have some CKB token to pay for the transaction fee.
Right. Yeah, we did that in the earlier step when we made the deposit, CK byte deposit. And so that created the account. And now we're using that account, which that's why we had to export our private key for MetaMask, is because that's where we also made the deposit. So this is deploying it to layer 2 now.
So what is the block time for the layer 2?
That I'm not sure on. It's probably fairly comparable to Ethereum. So, I mean, we're talking in general, probably 20 seconds or less. But sometimes when you're doing certain operations, the validator nodes need to pick up the transaction, and that can take a little more time sometimes. And then on layer 1, I should mention, is a little bit different than many other blockchains in that we actually use a variable block time. Rather than being set to a specific block interval, like Bitcoin's 10 minutes, Ethereum's around, I want to say around 15 to 20 seconds. Nervos is usually, it hovers somewhere between 7 or 8 seconds to around usually 15 to 20 seconds, somewhere in there. And the reason that it's changing is it's actually optimizing itself based on the current network conditions. If network conditions are kind of bad, it's automatically increasing the block time to make it more secure. And if everybody's connection is doing good that day, it's reducing it even further so that it can operate faster.
Okay, so it's more flexible. And so here we have our transaction hash. Our smart contract has been deployed. So that's a success. So now I think we are done for this task. Next, we are going to call a function of our smart contract. Let's check out the instruction. Okay, so let's scroll down. Before you begin on this task, you must first complete the first and second task. Okay, this is already done. You need the private key from Ethereum. We already have it. It requires the Gitcoin task instruction example repo, so we already have it. Okay, so prepare the smart contract and ABI. So in order to execute a function call on smart contract, it must be deployed and you must have the ABI that was generated. Okay, so we have it. This is in the simple storage.json. And we also have the address of the smart contract because this is going to be stored in simple storage.json. It's going to be updated. And after, in another folder, we have another file to do the call. We are going to go there. So call contract. Let me see what we have inside. Okay, so index.js. Oh yeah, and so here, one thing that we haven't mentioned before is that even though under the hood it uses Web3, actually it wrapped Web3 in another object. So Polyjuice HTTP provider.
Yeah, that's right. Yeah, so it actually does have a Polyjuice component here that's bridging the compatibility with from Web3 with our current layer 2. And so some of the later tasks will actually go a little bit deeper into that. But for right now, we don't really need to worry about that. We're most concerned with just filling in the blanks here of the missing values.
We did not save the address of the smart contract. Okay, I think we can just redeploy it. I think it's fine.
Yeah, we could just run the command again.
We are going to node index simple storage.json. I think that was the command.
Yeah, that looks right.
Okay, so let's deploy again. All right, so now we are going to save this. And we're going to replace the Ethereum private key here. So Ethereum private key, this is this one. And the contract address, this is this one. Okay, so I think that was the only two things.
You still need the contract ABI, and then we need to do the read function and the write function.
Okay, so let me see where is it configured. Read call. Okay, so that's the function that's the reading. So contract ABI, contract address. Let me see, where is this defined? Contract ABI.
Right. So in the instructions, you'll see we can actually just pull that out of that same simple storage.json.
Okay.
We could take that value out. I'd recommend pasting it into another text editor so we can just change it around a little bit, make it into one line. It'll make it easier to paste in there.
Yeah. All right. So yeah, this ABI here. Paste this in now note here, ABI, and you just want the array. So let's remove this. Okay, so back in index.js, and so for the contract ABI, where is it defined? Contract ABI here. All right, just have to make sure everything was pasted fine. Okay, so I think that was everything we had to customize. Then the instruction is node index.js.
Right, but we still have to replace the function names. There's still two more variables to replace. It's the read function name and the write function name. Okay, so what's going on here is the goal is of this is that they want you to demonstrate that you have the ability to, with whatever contract you use, you don't have to use simple storage.json. They suggest that you use a different one. You need to demonstrate that you can read a value from the contract and write a value to the contract. So all of this boilerplate that we see here is basically to do that. So just go ahead and scroll down a little bit, and I'll show you how to pop in the values for simple storage.json. So read call. Okay, so I see, there we go. That's right. Replace that with, let's see, this is the read call is just get, G-E-T, lowercase is what we need to replace there. Okay, and we can leave that one open.
So same API as a Web3. Actually, this is a Web3 object.
Right.
It's actually only the provider that is custom. That is
exactly. Yeah, it's basically a shim that gets put in there. Web3 itself is unchanged completely. It's the exact same one that you would use with Ethereum.
Okay, and here, what is the second method we have to change for writing data?
We change that to set, S-E-T, lowercase, and then as a parameter that we need to give it a number value, just any number that you want to put in there that will store into the contract. Okay,
so send. Oh, you mean here? We need to give it a value, right?
Yeah, right there, exactly. Yeah.
10, for example. Okay. And that's it.
That's it. Yeah, that's it.
Okay, so now node index.js, read call result. So the initial value was 1, 2, 3, and then we modify this to 10. So we have our transaction hash.
And this is, I believe that what we're looking at here, this transaction hash is a layer 1 hash. I'm not 100% sure on that actually, but it's doing a layer 2 action. But it's the two layers they're interacting with each other somewhere underneath the hood. And in just a few moments here, we should see the resulting value after it says confirmed and it's updated that value.
Okay, so we have the transaction receipt, and second time we should try to read the value. This time it's 10, so that means it worked great. So yes, we are done on this step. Next step, we are going to issue a token on layer 1 and deposit it to layer 2. So what does it mean to deposit a token on layer 1 to layer 2?
That's similar to the step we did earlier with CK bytes. It's putting an SUDT token, and an SUDT is similar to an ERC20 on Ethereum. So what's actually going on here is what we're going to do is we're going to create an SUDT token, which is just a single command on Nervos. It doesn't actually require a contract deployment because Nervos supports templated contracts, and we can use one that's already out there. So we'll create an SUDT token, and then we're going to send that over to layer 2. So it can be used by an Ethereum contract effectively as an ERC20. And one of the next challenges that's out there is actually to deal with that. It's the ERC20 proxy contract, which interfaces these two together. It's an SUDT that is being manipulated as if it was an ERC20, effectively kind of merging the two layers together in a way, but in a way that's completely seamless to the user. They'll never know what's all the steps that actually went into making this happen.
Let's do this. We open the instruction here. Okay, so yeah, so big difference with Ethereum is that in this case, we're not going to create the smart contract ourselves, but it's built in the blockchain. Go down. First step is to set up an account with testnet fund. So we already have it. You will be able to use this with the SUSDT CLI tool. Okay, so we don't have it. Use the SUSDT CLI tool. Follow the instruction in this tutorial to use SUSDT and issue SUDT token. Okay, so SUDT stands for Simple User Defined Token, equivalent to ERC20 token. Okay, so we're going to install this tool with npm. Go back to the terminal. Let's install this. So since we are installing this globally, it doesn't matter where we're running from.
Yes, that's right. It's just, it'll be a command that you can type in anywhere.
Okay, so we have installed this CLI tool. So let's make sure it works. We do SUDT CLI. What do we see? Okay, so it does work. Great. Okay, so issue SUDT token. So SUDT issue a private key. And so in this case, it's not going to be the private key of Ethereum, but it's going to be the private key of Nervos, right?
Yes, that's right. We need to use the private key that we created earlier. This is just to create the SUDT token on layer 1 of the testnet.
Okay, but let's say, so I create 100 token like this with this private key, and later I run the command again. So is it going to create 100 extra units of the same token, or it's going to be a different one?
Each time you run the command, it is creating 100 tokens, yes.
Okay, so but does this mean the 100, let's say we have two sets of 200 tokens, so are these tokens related to each other?
Yeah, they're all the same tokens. With the SUDT, you have the ability to mint as many as you need. So the total supply is basically just determined by all of them that are currently in existence. This is the mint operation to create 100. If you executed it a second time, you would have 200. A third time, you would have 300.
But how? So it seems like with this tool, one token is tied to one issuer. But how do you do if the same issuer want to create several tokens that are not related?
Oh yeah, I see what you mean. With SUDT in particular, this token standard, it's one private key per token. So this account it can only have one single token associated with it. If you want to create a second token, you have to create a second private key.
Okay, so yeah, this is different from Ethereum. Okay, so we are going to create 100 token here. So let's paste this. And for our private key, we're going to replace this with what we have in our node. So let's scroll up, and here this is the private key for Nervos. Okay, so let's put this here. All right, so enter, and it's going to create our token. So this time, you know what, I'm going to copy all the info in case we need it after. Okay, so we have a token ID of the issuer address, so that's our address basically, and the destination address, so that's the same. So that's these tokens are minted to us. We also have a transaction hash that is visible on the blockchain explorer for the L1 chain. Cool. So we've done this step, and we can check our balance here with our private key. So let's do this, check our balance. Once again, we need our private key. Why do we need our private key to just check our balance? Because normally anybody should be able to check our balance with our public address, right?
Yes, and that you can actually do that with this tool too. The reason that this exists like that is just basically convenience. Since this is a developer tool, we're operating with private keys. We thought it would be easy to be able to just use your private key to quickly check a balance as well. If you view the help for SUDT CLI, there's other options there where you would have to specify the SUDT token ID and also the address that you want to check the balance of. And in that case, if you provide those other pieces of information, then you don't have to provide your private key.
Got it. Got it. So here we can see we have a balance of 100 tokens. So this is working. Okay, so I think we've completed this part of the tutorial. So
yeah, we're done with that.
Okay, so let's go back to the main page. Okay. So set up the Godwin example tool package.
And we should already have that one.
Okay. So good. Then deposit layer 1 SUDT token to layer 2, create a Godwin account. You will need to execute the following command in the Godwin examples. Here, we need to prepare this command. So we're going to prepare it in our notes. So first, insert testnet RPC URL. Okay, so where do we have this already?
Yeah, it was in the first, if we go back to task 0 there, it'll be at the bottom.
Okay, this one.
Yeah.
Okay, so here, okay, insert SUDT log hash. Okay, so we have it just above. Okay, and insert private key. So I think this is the private key of Nervos.
That's right. This will be the layer 1 private key.
Okay, so let's do this. And insert Ethereum address. Okay, let me go back to, no, this is the private key, but our address, this is in MetaMask. Okay, so let's copy this and let's put it here. Okay, so and with this command, we're going to deposit some token to layer 2. Let's go back to the terminal and enter. Okay, so we had to wait to be completely synced, and after we execute the script. And just to be clear, if we modify the URL in our script, we can use directly the public node, and we don't need to run the indexer and the full node on our computer.
Yes, you would. That would mean that you don't have to run the CKB node and the CKB indexer. However, it's certain tools like this tool here, they have their own indexer built in, so they'll have to do a synchronization process also. And that one you can't skip. And also, so if you're using a public node, it's going to go much slower on that. So that's, again, why we really do suggest people run local nodes if possible. In the long run, it's going to save them time than having to use the remote nodes. Yeah, and compared to Ethereum, what's good is that we don't need to create a project on Infura or any API. We directly use the public node if we want. But yeah, I understand it's not the recommended solution. So I think it's exactly like when we did the transfer last time. So there was a first transaction on L1, and now we are waiting for the transaction on L2 to be confirmed. Yes, that's correct. And it should pick it up pretty shortly here. Usually there it goes. Cool. So now on L2, my Ethereum address has 20 token. Great. So it has worked. And what else do we need to do in this task? Yeah, I believe that's it. That's it. You just have to collect your screenshots and information, and that one would be done too.
Okay, great. So our tutorial is going to end there. But this is not the end of this Gitcoin hackathon. I really invite you to check out the other tasks. You see, you have many other to do, and actually, you can see you have some prize if you complete the task. Hurry up because there is a limited amount of prize, and it's really a great idea to make money while learning something new. And if you are stuck or if you have any question, you can also join the Discord chat of Nervos. So I will put the link in the description of this video. So thank you a lot, Jordan, to help us during this tutorial. That was very, very helpful. I don't think I could have made it without you. That was great to have the guidance of an expert. And yeah, I had a lot of fun with the tutorial. It was the first time I did a tutorial on something really different compared to Ethereum. So that was really refreshing for me. Thanks, Jordan.
Yeah, thanks. And it was fun for me too. It's definitely interesting watching somebody else go through all the steps, which we've done it 100 times, but it's a learning experience to watch you learn. And yeah, for anybody else watching out there, we're in the Discord, me and my coworkers there. So if you have problems, please join us. We're there to help you.
Awesome. Have a good day. Bye, guys.
All right. Thanks, Julian.